I am recording, people. I forgot to turn the microphone recording on at first. Oh, and I'll turn off the desktop audio. I use Open Broadcaster software to record pretty much all of my videos these days. So this is going to be a programming video, so a fair warning. There's going to be a lot of computer code and stuff that you won't understand unless you're a genius like me. So now, for those of you who are not aware, let's see here. Recently, I made a video. I forgot to load this before I started, but I'm going to go to my my videos here. Okay, so I have a YouTube channel, as you probably know if you're watching this video, and I have a lot of content on here. Now, I've done some incredible things. I have some color edits. I did a Super Mario Brothers, and I also played the first level of Sokoban here. But this video is the one I want to show you, BBM Box Adventures demo. I just want to show you a few seconds of this video. This is actually a game that I made. I call it BBM Box Adventures in case, I think it's pretty good until something else comes up better. But it's meant to be a Sokoban clone. So I've been playing Sokoban related games to get an idea of how it works. This is a video that I made of me playing my own game. Now, the game is not final by any means, but it is capable of doing some amazing things. So I'm going to probably stop showing you that, and I'm going to show you that the code that I used for that game, the code in its current state is here. I uploaded this to my binary bitmap SourceForge project. Now, the interesting thing is SourceForge has a policy that only open source projects can be on its site, which is fine because for now this is an open source project. Although I am the creator of all this code, there's nothing restricting anyone from downloading it and trying to compile it and install it. However, you will have trouble unless you know how. Now, I am going to be modifying some of this code, and I want you to know that the last update, the update just before I recorded that video that I just showed you, was September 11. It was actually about 4 a.m. of September 11, I believe. Or except, wait a minute. Yeah, I think so. Anyway, and there's a lot to explore. Now, technically, this is not part of my main BBM library. I call it binary bitmap because that is the project that I've been working on. But since I had an existing SourceForge project for my binary bitmap code, I decided that I would just use it to host my source code for my game. So what I'm going to do is I'm going to load my programming environment here. I have a lot of interesting stuff here, so many desktop icons. So I'm going to go to MSys2 64-bit shortcut. Now, I can use 64 or 32-bit, but I usually use 32-bit. There's only a slight difference in which architecture it's compiling for, but 32-bit is enough. So when I click this, it loads my little, you could call it a Unix or Linux type of emulator. So I have a message starting MSys2, start of batch RC, hello Chastity, welcome back to Unix. So this is a very interesting thing. So I'm going to open that console full screen. I'm not sure why, but so this is well, actually I don't need to do it full screen, because you'll be able to see it the same either way. So next I'm going to go to my folder that has my code. I'm briefly going to show you my main BBM project. I have several source files. This is the most massive of all programming projects that I did. And I'll give you a quick look at my Super Mario Brothers 1 code. this is the file that I used. I used my BBM library that I wrote, which is probably over 100 functions, and all it was doing is it was loading frames of a video, image frames of a video that I had extracted, and it would load each frame, and it would process it. It would do color alterations, and so let's just say I have a lot of code. So for example, I actually have this huge 22 kilobyte file. This is the one that stores my functions I wrote to create Windows BMP files, Windows bitmap files. So it can output several different types of bitmap files in the Microsoft Windows bitmap format, because I read about the format on Wikipedia and it gave me all the information I knew to know how to write my own stuff. Now, but just by looking at this, you get an idea of what kind of a programmer I am, because I do some complicated code. I use pointers, I use loops, I use a lot of functions, I pass a lot of arguments, I do a lot of stuff here. But basically, my BBM code, which I've covered in previous videos, is all in this folder, which I frequently back up. But what I'm going to show you today is actually a little bit different. I'm going to go to my Allegro folder. Also notice I have an SDL folder, which is kind of interesting. In fact, I wonder if I should show you really quickly. I actually have, this is, okay. I actually have a pre-compiled program here. So if I type main, then watch what happens. This is actually an SDL program I wrote, where you got 3 spinning polygons. So it continues for 1800 frames and then quits. So that's what I've done with SDL. As you see, I have a lot of SDL code, which I spent a great deal of time working on. I also have SFML code, but I never really went far with that because I hate C++. I mean, I like it because it's a programming language. I just don't like object-oriented programming. I suck at it, and I just don't see the need. So I'm going to go to Allegro. Allegro is similar to SDL, but it has a few different features. I'm going to go to my BBM Sokoban folder. Now, one thing to notice is if I try to click this program here, it doesn't work because it's looking for certain DLL files which are not in my path. And I don't put them in my default path because I need to know the names of the files. If I distribute my game I'm making for other people to download, I need to specifically know where those DLL files are so that I can copy them into whatever folder that I distribute this into. Anyway, so what I'm going to do is I'm going to use my little Linux emulator here, and I'm going to make sure I'm still recording all right. Yes, I am. Okay. Now, this uses all Unix style commands. So change directory to Allegro, and then cd bbm. I always use underscores. Separate my words. Sokoban. Okay. Now here's the key. Now, if I run that main file here, you will see that it does, in fact, it loads my game. It's very interesting. This is the game in the exact state it was when I last did it. However, something I want to show you here, I'm going to press escape and exit this game. And if you look at the console, notice that it's saving PNG files. Now, these PNG files go in this folder. However, there's actually more files here. You know what I need to do? I'm going to start modifying this code. That's why I have backups sorted by the date in case I need to revert any changes. So I'm going to start modifying my source code. I'm going to show you my source code, and then I'm going to start modifying parts of it. Now, this is the main file, the one that has the main function. I wrote this function that compares colors, and and turns non-zero if they're different and 0 if they're the same. Yeah. Okay, so, and if you probably won't understand this, like I had to learn the Allegro API. I had to learn a lot of things. So now a lot of this stuff is not Allegro specific, but some of it is. Some of it are structures like colors and bitmaps that the Allegro library uses. So some of that is Allegro, and some of this, like the constant and int variables, are specific only to the C programming language itself, but have nothing to do with Allegro. And I'm a C programmer. It's my most experienced language. So there's a lot of variables here. I don't have time to go through it all. I mean, yeah, sure, I could make an 8-hour-long video, but who would watch that? I'm going to try to keep this under an hour, but it's still going to be fairly long. So, the main function has to start out with several things. After it includes other files, that is. So, it includes levels.h and inputloop.h. So I'm going to also open those files because I'm going to be working on those. So we've got input loop and we've got levels. So here's the trick. Now it includes the header files with functions I wrote. It initializes Allegro, then it initializes the image add-on. And as I mentioned in the comment, it's for saving to files. So it saves those PNG files. However, when the program starts, I want it to delete those PNG files. So what I'm actually going to do, here's what I'm thinking. Since every time the program starts, I want it to delete those source files, I'm actually going to look at another file. My makefile. My makefile. This is my new makefile. It has several different commands I use. So, for example, clean removes the main executable, and it removes all of the files. In fact, I'm going to put a dot here because I like to put a dot before this and do, dot stands for the current directory. So, what I'm going to do is I'm going to add some code here to my main function, because the main function always begins. So, okay, so before it begins the game loop, there's a game loop and there's an input loop. I'm going to add a function here. It's the system function, part of the C standard library, that runs a system command. So it's going to run that command. Now, if you're running this under a Windows command shell, the cmd.exe, this command will fail. But I always write my programs with the assumption they will be run under a Unix environment. And if need be, I'll have to change that later. But you have to make certain assumptions when programming. You have to assume that your target audience has a computer. You have to make some basic assumptions. Okay, so now that I did that, I need to recompile this program. So first, let's look at what is in here. But now I'm going to show you. Now, if we do cat makefile, it shows me the makefile. So when I run the command make, it will automatically execute the first rule in the file. In fact, I could have showed you the file here. So this is compiling with everything. This compiles with the Allegro library plus the extensions of the primitives and the fonts and an image extension. So I'm using all the Allegro extensions for this. So I'm going to show you. Now when I'm going to clear this, and then I'm going to type make, and then it automatically runs that command for me. I got to say, new make, GNU new make, is one of the most convenient tools because you can customize make files to do anything you want. Now let's go back to here. Notice there's only a single file here now. Okay, so now as I'm going to move around a bit, let's see, I'm going to move this around. I can move green squares here. Now I can see that there is a slight delay because every single frame, that every time I press a key, it is saving an image file. So let's go back. You see all these image files? Every time that I'm pressing a key and moving something, it's creating a new image file. So I'm going to open this first file in, it's taking a while to load my image viewer, probably because I'm recording and slowing things down. Okay, so there's the first one, there's the second one. So my program is actually, it's actually saving a PNG file every single frame, which is really cool. I can change it to do other formats like JPEG or BMP stuff too, but you get the idea. However, what I'm going to do for the purposes of editing the code, I'm going to temporarily disable that. Now, the input loop is where the magic really happens, because once it starts loading, it loads the levels. Okay, I need to go in order. So first, we have level equals 0, and we start the game loop, and we have conditionals. If the level is 0, it loads the level 0 function. If the level is 1, the level 1 function. So we have levels. So this is the folder all about designing the levels, and designing the levels is the most time-consuming thing after writing the core of the program, that is. So I have a function that puts, you know, a movable box, one that puts the player where I want, you know, putting x and y coordinates, and then here, that is this right here, all of this that I've just highlighted, that is the code for level 0. But the exact arguments to pass was very specifically chosen by me, the exact place. And see, these other small functions up here are simply to save me time, because it multiplies the x and y coordinates by the square size in all sorts of cases. I'll get into that later. And it draws text onto the right side of the screen. There's technically two bitmaps. The bitmap on the left half of the screen and the bitmap on the right half of the screen. So that's a little bit interesting. And then there's level 1, which is a little bit more in depth because it had a whole different goal. And you saw that both those levels in the video I previously made. But after it loads whatever the current level is, then notice it calls the input loop. Both of these call the input loop. The input loop function is the one that processes all the keyboard output. So one thing that's interesting is every frame it's doing all this. If I wanted to speed it up, I could remove some of this, but as far as it's going fine. Now, it's basically an input loop. A loop that just keeps continuing until certain things happen. So it's drawing where the player's on the screen, it's drawing text to the screen. Now this is where I can enable or disable frame saving. If it's non-zero, it's considered true and the conditional happens. But if it's 0, it will not try to save a frame. What it does is it takes the current frame number, it makes a file name based on that frame number, and then it prints it to the console what the frame number is, and then if something went wrong, it says there's a problem saving that file name. And then, yeah, so it's very interesting. But I'm going to turn that off, and I'm going to exit the program here, because I'm going to recompile it. So now, so it will probably be faster, because I'm going to remake this program. And now it's a little bit faster because it's not saving. So I can move faster. Now I'm going to show you how this game works. There's green squares. Green squares can be moved. Now, blue squares cannot be moved, nor can I move past the white walls. However, blue squares are programmed to disappear. As soon as a green square touches a blue square, goes on the same space, then both of them are destroyed. So the idea is to make breakable boxes or breakable walls. And the yellow square, it exits the level, as I have in the text there. And then this second level is the same thing. Now, it takes a long time to beat this level because the way I designed it, I have to keep moving these things. Oh, I did not mean to move that into the corner, but it hardly matters. Now, I believe, oh yes, if I press the A key, the level restarts. Yeah, it's cool. So I can restart the level by pressing the A key anytime I want. And anytime I want to exit the game, I can press escape. But also, I'm going to show you something else. I can click the X here and it also exits the program. Now that you saw the basic layout, you saw what can be done in this game, I have to show you the input loop, because the input loop is what I spent the most time writing in this code. And I'm going to be making some modifications in this video, hopefully. So, what this does is, this is the AL wait for event. It waits for an event. So if an event happens, like I click the X or I press a certain key, certain things happen. Every key has a name. So this is the one, Allegro key A. If I press A, it restarts the level. And if I press escape, it exits the game. And that's because, see, as soon as the loop value goes to 0, the input loop ends. And then when the game loop value goes to 0, then it actually exits the whole game loop, meaning it won't try to load the level. Whereas if only loop goes to 0 but game loop does not, it will restart the level. So I coded that carefully. Now this part, it saves the location of where the current X and Y value of the player is. Now that's important because up here, every single frame, it takes wherever the old location is, it replaces that with a space or a black square. And then it draws where the player currently is. So where the player is at, the red square, it gets updated every single frame here, basically. So, but each key I press has to have code for it. So here's what I did. For left, right, up, and down, here's how it works. Now, there are several variables. Now, I use global variables, and I mean I use a lot of global variables. And all the variables are at the top of the file here in main.c. There's variables for each of the colors of these things, and then there are variables for multi-purpose X and Y. And I call these multi-purpose because I use them for multiple purposes. Duh. Okay, so anyway, I'll close the make file. I don't need that one open. And technically, I don't necessarily need the levels, but okay, whatever. I'll leave it open for now. So here's what it does. If this is all geometry here. Let's say if I press the left key, it prints what key I pressed, and the printf statements I could always remove or comment them out. So it takes the current location of where the player is, and it subtracts 1 from that. So the x variable and the y variable become the coordinates of the square that I'm trying to move onto. So it stores in these variables the x and y coordinates of where the square that the player is attempting to move to. And then it goes one more square in that direction, so x minus 2, because left, lowering the x coordinate means going left in this context. And it's going up in the case of right. And then the y values are used instead of the x values in the up and down functions here. So, well, not functions, but conditionals here. So it's think, where's the player going? and then what's the square beyond that? And this is all very important because this is where we get into some serious conditional code. And this was the hardest part to write, and I had to make a lot of edits because my game was not working the way I wanted. So here's what it does. It gets the color of the pixel using ALGet pixel. This is, Allegro, a lot of this is Allegro specific. So it gets the pixel at the place where the player is trying to move on to. And then it does some comparisons. So, like the comment says here, if it's a space, allow the move. So if it's a space, so for example, you have to understand the color. Now space, they're declared here, but they're not initialized until later. So each of the color variables is initialized later. Now, this is my black and white palette. I always use my black and white palette. So black and white here. Space is defined to be the first one, which is black, and wall, which is meant to be white, the second color in the array. And then I have green for the boxes that are movable, and then the box exit is yellow, and then the goal. Now, I want to rename this because technically those blue squares are not necessarily a goal. They probably need to be renamed to something more appropriate. Come to think of it, since I've mentioned that, how about I do that now? So we have box exit. So I'm going to rename goal to box break. Yeah, so I could call it breakable, but I just want to call it break. Now when I do that, I'm going to get an error. If I only change that part, I'm going to get an error. So it's like box break undeclared, first using this function. Okay, so what we're going to do here is every occurrence where goal appeared, I need to change this. So we need to declare the okay, where's the declaration here? Yeah. Okay. So it was originally going to be the place where I put a box here. So put a breakable box. And I'm showing you the errors because I want you to see how programming is really like. Programming isn't always pretty, and there's a lot of errors. So we have the put goal function. We have goal undeclared. So here's what we're going to have to do. What I'm going to have to do here is I need to change all occurrences of goal to box break. So first, let's find all occurrences, and we're going to match case 2. Oh, that's right. There is no box break in this. So So there's goal there. There's goal there. Goal there. Yep. Yeah. There's a lot of interesting things here. So what I'm going to do is I'm going to take all occurrences of goal, and we're going to replace it with the new name. We're going to do that. Okay, so let's see what it does after making that modification, because it's going to replace all occurrences where I use that variable. Let's see, where is box break? Because I know that I put it here. Yeah, for some reason I'm just not seeing it here. Yeah, here it is. This is where it compares for a breakable box. And after I finish renaming this variable, I'm going to go into the explanation of what was going on. So now notice that in the in function put goal. Yeah, so here's the thing. There's still one file where things have not been renamed. So here we're going to do this again. We're going to replace all. We're going to replace all where it says goal with box break, because I need a more descriptive variable name. So now let's see if there are any more errors. Now it still works. It works as it did before, and things work. Now I want to show you when I try to push this green box into that, I'm going to show you the exact code that makes that happen. Let's go back to the input loop. So first of all, it gets the color at where the player is trying to move on to. Then it compares it with the space. If that is a space or if it's black, it allows the player to move to that location. It updates player X and player Y. If it is a box exit, if it is an exit or a yellow square in this context, it ends the input loop and increments the level variable so it will go to the next level. So that was the easy one to do. Yeah. And then if it's a wall, if it is a wall, the white wall, or the blue squares, the breakable box, it will not let the player move here. So I have a comment saying nothing moves if wall or unmovable box break found. So it doesn't allow the player to move on to a white or a blue square. Now here's where it gets interesting. If it compares with box, which is simply a variable for the green color in this case, because it's meant to be a box Sokoban style, and it's defined as green. If you look here, if we go, you can see that the green squares are defined as green here. So and the comparison function, I'll show you that comparison function, because none of this works without this comparison function. This compares one Allegro color to another. So it gets everything is sort of in a structure with red, green, and blue fields. So it's comparing that pixel to that color. So back here, it compares it to the box color or the green square. And then if it is a green square, we want to check to see if that square can be moved onto. So here's what we do. Now remember that the x1 and y2, the x1 and y1 variables were defined as being two squares in a direction from where the player was. So if the player is moving down, then player y plus 2 is that spot. So here's what it's doing. First it compares and sees if there is a movable box, and then if there is, then we have to get the pixel of the square beyond the box, and then if that's a space, so if it's black, then we can move the box onto that space. So what it does is it can move onto that, so it sets the target bitmap to 0 because it's going to be drawing to the bitmap, and then it draws a filled rectangle. It draws a box at that location using this particular AL draw filled rectangle, which is actually a very useful thing. So it does all this code. So then it draws a green square at that location we're trying to move the green square onto. And then it updates the player X and Y variables so that the red square will be drawn where the green square was just moved away from. And that's how it works. That's how when I move a green square, it moves beyond. But it won't allow me to move that green square unless there's either a black square or a space on the other side of that, or if it's previously goal and now box break. So if it's the box break color, which is blue, then it prints a message that both of them are destroyed, and it does a similar thing. So it's the target bitmap here, and then it draws a filled rectangle there, but it's going to put a space there. So the player is still updated to where the green square was, but where the blue square was is replaced with black. So the green, so basically, let's start over. So then you see now that's all the logic of how this game works. And so as you see, we can't move a green square onto another green square, and we can't move it onto a yellow square, and we can't move it onto a white square either. But we can move it onto a blue square, which then destroys them both. So I designed this with the idea that, well, what if we want to have breakable walls, you know? However, here's where things get interesting. Now, I want this to be, I'm starting this out as a Sokoban clone. So what do I do if I want to have because you know in Sokoban, you have locations where the boxes are supposed to be moved to, but you are able to move them to those spots, but you're also able to move them to a different one of those spots or to somewhere else. So I need a target or a goal. So there might be an actual goal for where the boxes are supposed to be. But I need to code this carefully, and I don't know if I'll be able to succeed in this video, but I'm going to try. So I needed to think for a minute there. So here's what we're going to do. What I'm going to do is I'm going to update my code here. I'm going to change level 1. Now keep in mind the level designs are by no means final. They can be changed at any time because this game is still in the early stages. So I don't have a predefined level set that will always be available unless you download the September 11 source code yourself. However, if somebody out there watching this has an idea of a level to make, you can send me suggestions. You could even design a level yourself. You could design your own Sokoban level, or you could design a maze. And if you design a level and you want me to include it in my game, I can actually do that because I have access to the code. It would be time consuming to figure out how to convert what you send me into that, but I could do it. So I'm going to make a new function. I'm going to have well, first of all, I need to make new variables. So what I'm going to do is I'm going to make a new color variable. Now, there's a reason all of the variables are defined here, and then later on they are defined after the main function begins. That's because I want them to be global variables. I don't want to have to pass all of these 20 variables to every single function. They have to be global so that every function has access to these colors and the player position. And I know that programming courses and programming books tell you not to use global variables. Some of them say that you should almost never use them. Some say you should never use them. But from my programming experience, use global variables. They will save you a real headache. When you're making a small game such as this, you want global variables. If you're making a larger project, yes, you do need to have, local variables. I'm not going to lie about that. But this is a small project, and I have the full source code myself. If you're the only programmer, use your own global variables. You know what you're doing, so you don't have somebody else messing it up. We're going to make a new Allegro color, and we're going to call this, should we call it box goal or should we call it box target? I wonder. Let's see. I could call it box goal or, well, I'm going to call it box target is what I'm going to do it. Or I could call it box dest, short for destination, or box destination, or something like that. So I'm going to call it target for now. Box target. Okay. Color of the place to leave boxes. So now you'll notice that I created that variable, and the program still compiles and runs, but that variable is not being used anywhere. So now let's try something. Let's take this box target variable name, and let's go down here later to where, because now these variables, there's a reason they're defined here, and that's because there's no point in declaring the color variables and initializing them if Allegro fails. So if the Allegro library can't be loaded, or the window can't be displayed, or the keyboard or the fonts or anything can't be loaded, then we're not going to bother initializing the colors. So initializing the colors comes after we make sure the program is actually up and running like it's supposed to. So box target, now I'm going to show you something. Now if I set box target to, like, for example, OFFOFF, for example, it's not going to work because it's going to say incompatible types when assigned to Allegro color from type int. So I'm trying to assign it to an integer. Now in the BBM library, my main C standard library code, then that would be a valid color. That would be magenta. But instead, we're going to have to use the AL map red, green, blue. So what I'm going to do is I'm going to copy this, and then I'm going to copy this here. And let's try something. Let's try setting it this way. So if I do this, now it compiles and runs fine, but you see nothing visually has changed because we've declared a new variable, we've initialized it with magenta, and then we now we have yet to put it in the level. So I'm going to make a new function. So we have put player, we have put box, we have put exit, we have box break. I'm going to do something here. Now these functions are very easy to write. They're all very similar. So we're going to have put target. So we're going to put target. Now, but the variable is actually called box target. So it actually it doesn't actually have to be called put target. It could be called put box target. Let's just call it, because I have put exit for the variable. Let's see, where was I? Yeah, for the box exit color. So let's just have this put target. We don't need to use the whole name, but so we're going to do box target is the color that it's going to be. Now you'll notice in level 1 we had 2 green squares. We only need to have 1 green square here. So that's the thing, is we're going to have 1 green square, and this is going to be interesting. So we're going to change level 1. So that's level 1. I want to go to level 0. Yes, there is now a level 0. Okay, so this one at the top left, there's one at the top left, there's one near the bottom left. So let's try something. I'm going to change this one. Instead of put box, it's going to be put target. So I'm going to save that. So instead of a green square where there will be a magenta square. Now this magenta square cannot be interacted with. It won't let me move on to it because the code is preset to only allow moving to a black or a green or a yellow space. It lets me move on to the yellow space and then goes to the next level. But here's the trick to it. So we have this magenta square that we can't really interact with. Now this is going to be the location where the green square goes. But do I really want to use that color? I'm not sure. Now, keep in mind, I have the source code. I can change these colors at any time, but I do want to have a consistent one. So like if someone's used to my game having movable boxes being green, I don't want to switch the green and blue colors around and confuse everyone. Then people will think, wait, what did you do? Why did you change the colors? You know, so I kind of want to have consistent standard of what color boxes do what. Now, just a word about why am I using colors of squares rather than loading image files? Quite simply because it takes less code and it runs faster to just draw solid colors of squares. Oh, and also, the square size variable. Notice the square size variable is 40. That means it's 40 pixels. So I'm going to show you something. First of all, I'm going to change the colors here. Well, like for example, let's try, I know what I'm going to do. I'm going to change this to be, I'm going to make this cyan. And watch what happens if I leave out the 0, because there's supposed to be 3 arguments. Yeah, it's like, yep, there's something wrong there. And if I do it only 2 arguments, then it's going to say there's not enough arguments. Too few arguments. See, I told you. Okay, so we're going to do 0, 255, 255. And then I'm going to make another change. I'm going to change this from 40 to 10. Let's see here. So, and by changing the square size, see how everything's tiny now? The size of it is tiny. Yeah, I made it smaller, so I can make bigger levels by making the squares smaller. And now this square is cyan, but it still can't be interacted with in any way, so I still need to add code. And just for the fun of it, I'm going to do square size 20 and show you that by changing that variable, now the squares are not as small as they were, but they're also not as big as they were at the beginning. So what happens if I change it to 80? Will my program even still run? I don't know. Honestly, I couldn't tell you. Whoa. Okay, that's weird. You can't see the red, the green, the blue, or the yellow squares. Okay, so let's change it back to 40. There's a reason I chose that size. Oh, and just for your information, the size of the images, the screen is 1280 by 720, a YouTube standard definition. And the width and height of the sub-images that are drawn to, including the level as well as the text images, width and height are set to screen width divided by 2. So they're going to be 640 because 1280 divided by 2 is that. Because they're meant to be perfect squares. Even though the screen itself is YouTube standard definition, the images themselves are meant to be perfect squares. So that was the perfect size I decided, really. Okay, so anyway, so we have this working. It shows me all the keys I pressed. So now we have this, so we want to be able to interact with this. We need to be able to interact with this particular thing. So here's what we're going to do. We need to make it so we can move the green box onto that square. So let's do that. So we're going to take some code here. So we know if it's a space, it lets me move that onto there. So let's try something. We're going to add another conditional. We're going to do a special conditional here. And we're going to have, okay, if it's a space or if it's we're going to put this sandwich this between here. So we're going to have this conditional here. So this conditional statement here is going to be if it is the color is box target. So it is, now let's try this. Let's try recompiling and running this. Now, what does it do? It still doesn't let the player move, but now what happens if I do that? Yes, you see? The green square goes there. But notice as soon as the green square goes away from it, then it disappears. Now, it's interesting. We also could have done it this way, because notice there's very little difference between this line and this line. So it fills that square with that. So we could have it if moves the box onto it, but we could also have put the space color here. And let's see, if we put the space color, then it will behave the same way as if it had been a blue box. So see, that one disappears the same way it previously the blue box disappeared. So we can do that, but what do we actually want? Well, I do want, okay, yes, we do want the green square to be placeable there. So there's no denying that. So let's change this. So we want the green square to be movable there, but we also want to be able to move that green square away and have that box come back. So how do we accomplish that? Well, I'm going to have to add some code, and here's what I'm going to do. Now you'll notice that I have, okay, let's just look at that again. Look at all these things I have. We have black, white, red, blue, yellow, green, cyan. We have 7 colors. Magenta. There are 8 extreme colors that I like to use. They're my color preference, and they're the on-off switches of full of the primary colors or none of them at all. Magenta is the one of the colors we're missing. So here's what I'm going to do. So I'm going to have a new variable, color of a box at the place it should be. We're going to make this be box placed. So we're going to have a color that represents the box placed. So now we have this new variable. Next, we're going to initialize this new variable. This is probably not the most elegant way to write code, the way I have everything scattered. I probably need to put the Allegro initialization functions in a separate function by themselves, but I didn't want the overhead of another function call, and I didn't want to add more header files, so whatever. I can modify the code however I feel like. The point is the computer doesn't care. The computer runs my code because everything is installed. Oh, and by the way, in case you're wondering how did I get this Unix-like environment? And also, look at my path variable, echo path. It has access to several of my Windows folders, so I can type dir. I can do other things like, well, I can't think of anything else I want to show you. I wonder if Del works. Nope. Anyway, so now we have box placed. Now we are going to use magenta. Oh, yeah, I forgot what I was going to say. Is now this environment that I have here, I'm going to show you. It's basically it's not technically an emulator. It is in my main C drive. We have MSys64. Now I also have Cygwin64. Cygwin64 is a sort of, it's also a similar emulation of a Unix-like environment under Windows. It's just slightly different. I've been using MSys64 recently because I like it. But Cygwin also works, but I don't have everything installed with it. So we have the Mingwei 32, like it has everything. So this has all the Allegro DLL files. It has several Linux or Unix utilities, several commands. Most of them I don't even know what they do. I even have Cargo, which is actually for the Rust programming language. I have so many things here that I don't even know how to use, but I installed a lot of packages in my system here. So go to, like, I think it's msys2.org or whatever to go. You could, but if you look up msys2 or msys64, you should be able to find this and install your own Unix inside of Windows. And I do this because I need Windows for some things on this old computer, and even though I like Linux, so I'm giving myself a Linux or a Unix. And Linux and Unix are almost the same. They're different, but I'm not going to get into that. I like Unix because it reminds me of unicorns. Anyway, let's go back to my folder here. Okay, so box placed. Now we are going to use magenta. So let's do that and then put the 0 where the green component was. So now, yeah, it can, oh, yeah, we got to type make here. So now we have this going. So I haven't modified the other code. So see, the green square goes there. But here's what we're going to do. Now I'm going to go to the input loop, and we're going to have, as soon as it compares and the green square moves onto a box target, if the square it's going to compares to the target, then we're going to have box placed. Okay, so now let's see here. So now we're going to try this. I move the green square onto the cyan square, but notice now we have a magenta square that cannot be moved. Isn't that interesting? So I can move it any old way I want, but now we have a magenta square that cannot be moved. So we want to be able to move the magenta square. What if you moved a box onto a cyan square and it turned into magenta, but you need that green box back? Okay, this is getting very interesting. So I need to add some code for that. Okay, so, and one thing that I want to do here, I've modified this code extensively. So I think I'm going to show you how, well, I'll show you that later. I don't want to add time to this video. I'll back this up in a few minutes because this video is almost to an end, but I need to add code for what happens when we have a magenta square. So let's say, what if the player is moving on to a magenta square? So we're going to have, if the player moves onto, if it moves onto a box, then it does that. So it's going to, okay, I know. It's going to, okay. Let's see, I'm trying to think how I want to do this. Well, I think I will just put, I'm not sure where to put this code. I'm not sure it matters. For right now, I'm going to put it right after the space. So if it's space, the player moves. But okay, what we're going to do here is we're going to do something here. So if the player is moving onto a location that is box placed, which is magenta. So box placed is magenta. It will then allow the player to move there. Okay, see, I'm recompiling and rerunning the code each time I make a small change. This is how real programming works. When I spend hours programming, this is what I am actually doing. Okay, so now what happens? The green square will be moved there, it turns magenta. Oops, but see what happened now? Now that the player moved there, this is where it gets complicated, okay? Now, yeah, see now the player has moved on to it but overwrote it. So how, okay, also the green square is gone. We want the green square back, so let's make another small change. So not only will it update the player X and Y locations, but we need to also draw the filled rectangle of where the box, and notice that I'm using the AO draw filled rectangle function instead of using my put box function, because it would actually take less code to do put box, which calls that long function. I could save myself code, but there's a reason I'm doing it this way. What if I change the functions, say from put box to put box movable or put movable box? Then if I change the name of the function, all my existing code will break. And I don't want that. Sure, it'd break the level code, but I don't want to break. So I'm going to keep using the built-in function here. So I, what did I do? Yeah. Okay, yeah. So I'm going to put this here. Okay, I'm going, and that line is too long. So if the wait a minute. Oh wait, that was the wrong place. Not if box exit. If I'm moving the player onto the location, and notice I indent my code here. I indent my code so I know which loop goes with which. So first, if I'm moving the player onto a box placed variable, then we're going to put the green box onto the square beyond. Let's see what it does now that I added that. I hope I did that right. So we're going to put the green square there, and then we're going to move it. Wait a minute. Wait, I need the green square to appear. Wait a minute. Oh, I think, wait, what did I do? Wait a minute. Okay. Because I know that I want the green square. Okay, I made an error here. I haven't found out where my error is yet. So ordinarily, when we have a movable box, so if there's a space, then it's drawing that particular. It's drawing that there. Did I do it right? Yeah. If it's placed there. Okay, let's check this out. Is the code identical? Yeah, the code is identical. So it should be moving. It should be drawing the Yeah, because if that pixel has what have I done? But yeah, box place equals 0. Yes, it updates that, but what have I done wrong? I did something wrong, and I'm not sure what. Okay, let's try this. Okay, the player. Yes, the player goes onto that square, but why is the green box not appearing? What did we do? Something's not right. That's just weird. Because ordinarily it works. See, when the player moves onto the green box, yeah, then it does that. Huh. Notice it can't remove those image files because there are no image files, but that's not really a problem. I can't figure out why this program isn't working as I intended it to. Because ordinarily, if, let's see here, because if I'm moving, if the player is trying to move onto that, yes, yeah, yeah, because that's strange. Because yes, the player, which the player cannot move onto it directly. Okay, yeah, until it turns magenta. Then when the player moves onto it, yes, the player is meant to be at that location, but the green square is not appearing. I did something wrong. Okay, so yeah, it's putting, oh shit. Of course. I forgot to set the target bitmap. I am so embarrassed. Sorry guys. Notice that the other one set the target bitmap to bitmap 0 before it tries to draw a filled rectangle. And there's a reason that's important. Allegro has an interesting system. Okay, so first it's going to update the player variables, but we have to set the target bitmap to 0. In fact, I want to show you something. Okay, first let's get it working. Let's get it working as it's intended to be. So let's move the green square onto there, and then let's, yes, it works. See, you see that? So now the player moves the green square onto the cyan square. It turns magenta. And then when we push the magenta square, it turns, yes, it turns the green, that magenta square turns green again on the other side. But how do we restore the cyan square? Ooh, yeah, how do we restore the cyan square? That's an interesting concept. Also, now the places where the boxes move in a Sokoban game is the player can move over those spots. Oh. So in other words, here's what we have to do. Okay. So, all right, yeah, I need to figure this out. Okay, yeah. Okay, so let's start over here. The player should be able to move onto the cyan square itself, regardless of whether there's a green box that moves onto the square, because the green box should be movable on the spot, but the player should also be able to pass through that square. So here's what we're going to do. So if the okay, so if the location where the player is trying to move is box target. Okay. Okay, now, all right, now this checks for a box target, but this is under the subcategory. So these conditional checks are about moving the box, but this only happens if a green a box is being moved on this way. So it turns it magenta if, yes, it turns it magenta if the green square is moved onto there. But what happens if a player moves onto it? Well, first of all, we have not allowed the player to move onto a box target. So what we need to do is we need to have a conditional up here. So if the player, Okay, so yeah, okay, I think I'm getting this now. This is complicated. So yeah, if it's a black space, the player moves onto it. If it's a placed box, it moves into it. But we also need a conditional here. If the player is moving onto a pixel, notice it only gets the pixel value once. Well, actually, it checks the pixel twice, because if there is it gets the pixel of the place beyond where the green square is moving onto in this conditional. But that's part of only if there's a movable box that's being moved. Only does it check the pixel at the square beyond. But right now, we're checking only the square that the player is moving onto. So if okay, so if the player is moving onto that, okay, now first of all, I have the skeleton of it, but currently I only have the conditional there. The player still can't move onto it yet. So we're going to change that. So we're going to allow the move. Notice it updates the player X and the Y, and notice the frame number. The frame number only gets incremented if the player is actually moving, or a box is actually moving, or something is actually happening in the game. Oh, that's interesting. Oh, check that. Oh, well, that wouldn't do anything. Actually, it will probably mess things up, because if I have the frame increment by 2, then yep, it went straight from 9 to 11 there. I see that. Okay, but yeah, we only need 1. So it's going to update the player position. And then, so here's what we need to do. Okay, I see. So, yes, so as soon, yes, we need to make sure that the color of where the player was at becomes that original color again. Ah, I get it. Okay, I know what to do, I think. Okay, so here's what we're gonna do. I think I have an idea. So if a oh yeah, I know. Okay, oh yeah, I think I get it. So the player ordinarily moves through only black spaces. Yes. So okay, I get it. So ordinarily in the input loop, notice that each frame it's updating the yes, it's updating the it draws a space. It draws black where the player previously was. Oh, I see. Oh, I get it. Oh, brilliant. Okay, so here's what we need. We're going to have yet another color variable. I know I'm adding a lot of color variables, but this is where it's going to get interesting. So, yeah, I have a lot of stuff. Player color, okay. So, we have a lot of variables here. Yeah, and the pixel, oh, I see. The pixel there. Okay, let's have another variable for okay, so yeah, so it's going to be let's see, old color. Okay, that's an idea. So we're going to have old color. So color, yes, color of a square before the player moved onto it. Yes. Now this old color variable, what is the color going to be? Interesting. Now it's going to be a variable that stores what the color previously was. Okay, so here's the thing. So we have, yeah, I don't need to change the level. Okay, so we have, so each frame it restored when the old location of where the player was at, so will become the old color. But the old color, okay, let's see what happens. We haven't initialized the old color. So what happens? Oh, isn't that, oh, come on, man. Oh, that's cool. That is sweet. That is super cool. The old color. Okay, I see what's happening. It's not updating it with a new color because we haven't defined the color. Oh, okay, yeah, that, oh, that's what happens if you don't clear the old color. That's why I put this code. Okay, I know how to fix this. This is hilarious. Okay, so here's what we're going to do. Whenever the player moves, okay, so okay, I need to figure out an efficient way to do this because the color where the player was at needs to be updated whenever the yeah, okay, yeah, I'm trying to figure this out. So we're going to allow the okay, the player can move onto where a box is placed. They can move on to where the box target was. Okay, oh, I know what to do. So the player, okay, I get it. The player is only updated once. The only part of my code that actually draws the new location of the player, yes, is going to be, yes, this is very cool. Actually, I'm going to do something just for the sake of fun. We're going to initialize the old color with something else. Okay, so the old color variable, let's make it something really freaky. Let's make it let's make this value be 128. Okay, let's just try that. Let's try seeing what happens. Old color, yep, it makes a new color. So there's a trail and it boxes me in. I can't move anymore. That's funny. So yeah, so let's I know. So hey, I know what I'm gonna do. We'll have the old color. We're going to have this be 128. Oh, hey, yeah, I know. Yeah, this is cool. I'm having fun with this. This is cool. Yep, it leaves a trail where the player was. Okay, let's move. Yeah, 128. Okay, so this will be gray. So now all of those, because if it was all white, it would all be white. So now it makes gray. Now gray is not supposed to be in here. So gray is an error. So gray code here. Okay, so gray is a color that is not supposed to be in the universe of this game. So we're going to correct that. So at the start, it's gray. But then, here's what we're going to do. It's going to, each frame, the input loop, before, okay, we're going to get the pixel. We're going to get the pixel. Yes, we're going to get the pixel where the player is currently at. So keep in mind, okay, we're going to get the pixel of where the player currently is. Okay, yeah, this is going to be old color. Come to think of it, the code isn't right yet. It's currently, I copy pasted it from where it's checking where the player is moving on to. So what happens, okay, let's see what happens here. Oh, okay, whoa. Whoa, strange. Oh, yeah, that's not right at all. Okay, that's not right. So it's going to get the old color is let's see, wait a minute. Okay. So yeah, so where the player is, okay, so we're going to get for player X and player 1. So we're going to get player X and player Y. Okay. So it replaces with the old color where the player was at, but then this is important. So save color of where player is moving onto. Okay, yeah. So it's going to save the color where the player is moving onto. It's still not working right. That's weird. Why isn't it working? Because it's trying to move the... Oh, wait a minute. Oh, it's getting the... Oh, duh. I feel so dumb. Okay. Player... Oh, okay. Player X and player Y is where the player currently is, not where it's going. Okay, I get it. So instead... Alright, I get it. Alright. So let's try something. Let's, instead of player X and player Y, let's have, yes. Okay, yeah, that's good. Okay, so X and Y are, because those are where, okay, yeah, that's right. That's where things are at here. It's still not, yeah. Oh, it's, whoa, weird things are happening. This code that I'm doing is not working right. Okay, so wait a minute. Because the, oh, duh. Wait a minute, wait. Okay, I get it. Old color. Okay, we're not going to have it. Okay, yeah. I know. Okay, yeah. So here's what we're going to do. We're not going to have, okay. I think I know what to do. We're not going to do that there. That's going to confuse my program. Instead, we're going to be more specific than that. Okay, it's currently gray. So now, here's what we're going to do. If the player is moving onto a space, okay, if the player is moving onto a space, it will allow the move. Okay, yes, it will allow, yeah. Okay, so, all right, I think I got this. If the player, instead of getting the pixel, we already know what the pixel is. If the location of the pixel we're moving on to, because that's already predefined as part of this, then not only is it going to update the player, we're going to make old color equals, yes, old color, yeah, it's very interesting, old color equals pixel, because pixel is what was the previous color. Oh, I forgot to put the underscore. Okay, so old underscore color, yes, equals pixel there. Okay, yes. Oh, it works, but it doesn't do it. Okay, yeah, let's see. So let's see here. Yes, it's working because it saves. Okay, it's saving that the color is black that I'm moving on to, and then yes. Okay, so here, very interesting. It's still not working like I want it to though. Why is it not working? Okay, so I think I know why. Because if it's a space that we're moving on to, it updates the old color so it's not gray. Because remember before when I did that, because we can, it's cool how it's I'm updating that. Okay, so see, before it was gray, but then it updates it because we have old color equal, and because now the colors are structs, but apparently a struct can be assigned to another struct of the same type with an equal sign, which is something I did not know about C programming, but it's good to know. I don't use structs in my own programming. Structs are part of SDL and Allegro and SFML. I just don't write my own structs. I have very limited experience with them, so one of the things I need to learn, but apparently you can do that with structures, because I know that the Allegro structures can be done like that. They can be assigned to another struct. Okay, so it works. So now here's the problem though. Now I'm going to explain why it's not working, and I'm gonna show you the fix. So it's updating it with the black, the previous color, but then when we move on to there, then yes, it does that. So we need it to restore the old color. So now if it's a box star, then it has to save. Yes, it has to save that color of the pixel of that target. All right, yes. So let's see if it works. So, wait, what? Oh, come on. Oh, that's not right. Oh man, I screwed up bad. Now you see. Okay, yeah. Now you see it. As soon as I try to move away from it, it's messed up. See, because it moves onto it, but then it updates the color of it. Okay. Right. So, wait a minute. Okay, wait a minute. So we messed up here. I messed up bad here. Okay, so old color pixel. So the old color doesn't need to be stored there. No, that's not what we need. Okay, so it's going to, so what we really need is so that well, we do need it to save. Wait a minute. Wait a minute. I'm trying to figure this out. This is getting complicated. Yeah, what have I done here? Because I want the cyan to come back to where. Yes. Okay, I get it. So yeah. Because when we're moving onto that square, then that's fine. And then as far as, yeah. Oh, weird. Yeah, because see, when the green square moves onto that, that's great. Yeah. Okay. So I still messed up. So we need a way to restore. It's because it's when the what we do need to store. Okay, we do need to store. This is getting crazy. So wait a minute. Wait, what have I done? Okay, so the player can move on to the box target. And then it stores yeah, see, this is why programming is hard. Okay, so but then we want to make sure that color is restored. I'm going to have to do this differently. Okay, so whenever we're moving onto a space, it stores that. Yeah, that's correct. But yeah, that's just very weird. Okay, so when we do need to save that it was a okay, but here's what we need to figure out. Okay, I think I get it. Wait, okay. So we do want to store the color of the pixel when the player is moving onto when the player is moving onto that, then the old color will be that particular pixel that we moved onto. But here's what we have to do. We have to stop it from okay, this is where it gets very tricky, because I have to make it so that the old color doesn't become at the previous square when I move on to it. It has to as soon as I move away. Okay, so here's what we're going to do. So, so the old color does get there, but how do I stop it from being? Wait a minute. Oh, I'm actually having a headache now, man. This is hard. What am I doing? So, okay, so we have the, because every single frame in the input loop, it is replacing, Hmm. Wait a minute. Yeah. Because do we need it to do that every single frame? I don't know if we do or not. Because, see, the square only moved on black ones previously. And even when, like, the square it was previously at was always black, so there was never an issue. So, we have to find a solution here. Oh man, this is complicated. Okay, I know there's a simple solution, it's just that I'm very tired, so I'm not smart enough to think of it right now. Alright, so if okay, so wait a minute. I wonder if there's something that can be done here. Because where the player was previously at, yeah. Okay, so oh, wait a minute. Oh, I know what to do. I think. Okay, so ordinarily the code that every time the player moves gets replaced with the old color, well, that's based on the okay, so wait a minute. Okay, clear old location player was at. Except wait a minute. Player x1. Wait a minute. Oh, okay, yeah, because player x1 and player y1 was the temporary place where because the player's old location is stored here before okay, so before the player moves, and that's why he did that. But so what we're going to do is we're going to okay, I think I know. Okay, so what I'm going to do is if we update the I still feel like there's a more elegant solution than what I'm about to do, but this is a work in progress. So we're going to go over here. So when the so when the player is moving onto a space, or if it's moving onto a box target, it saves the old color of the pixel. But what we're going to do is we're going to set we're going to copy this code from earlier. Yeah, we're going to the old location of where the player is. Okay, yeah, this is where it gets interesting. So where the player is going to be, the old location of the player is going to be replaced with the new location. So the old location and the new location will be exactly the same. So that's an idea. Let's try this. Then it's still acting weird. Yeah, what in the world? What Why is it not working? Oh, I warned you this might be a long video because I've got to figure out what is wrong with my code here. Yeah, so the new location. Wait a minute. Yeah, something has got to be done here. Okay. I'm going to have to modify some code or this is not going to work right. So yes, so we know that when the player moves on to a box target, it does that. But we need to set a variable. Yes, okay. We need to have some conditional code here. Okay, yeah, this is getting complicated. So, what happens if I don't have this? Okay, so this is where it tries to draw where the player was at. But it's not doing that. So ordinarily this code is good. Ordinarily it is. But it's working against me now. Because now it's trying to yeah, that's very weird. Okay, what is going on here? This is long. But I'm started now. I've got to finish this. So we know that, right, so, okay, so we know that we are trying to, yeah, so the, okay, so the old color, yeah, okay, so, yes, so we definitely do want the old color there. It's, yeah, it's stored, it's a space, and it's also stored if it is a, yeah. Yeah, this is weird. Because see, things work sort of as expected there, but oh, that's interesting. Yeah, because see, when I move a this green square onto there, then yes, it does. Yeah, but we still need to be able to restore it. So, hey, I know. So, oh man, you know what? I'm having a hard time figuring this out and I need to eat. So I'm going to end this video and continue this in a future episode because this is getting too long and I have not figured out how to fix my code. So thanks for watching and hopefully there will be a part 2 after I finish this.